Hello, everyone. Welcome back to our ASL Connect lecture series. My name is Noe Turquoise. I'll be facilitating this conversation. Right now, I'm wearing a black shirt with white buttons, black glasses. I have a beard. I have a blue background, and I'm looking forward to listening to Atomic Hands presentation. This program was set up by two deaf women, Dr. Barbara Spiker and Dr. Alicia Wooten. So we're looking forward to listening to what they have to say to us today. Atomic Hands is set up for, well, Alicia and Barbara will actually go into great detail of behind the scenes and tell us what they have done. And this is a chance for you to pepper them with questions. If you have any curiosities, this is a great opportunity to ask them questions. We'll be using the Q&A feature down at the bottom if you have a question. So go ahead and ask your questions there. After their presentation, we will leave time, I'd say probably about 20 minutes after the presentation for Q&A. You can use the chat feature as well, but we do encourage you to use the Q&A for questions. So I look forward to listening to their presentation. I hope you guys enjoy and learn a lot. Is everyone ready? I'm going to hand it over to Barbara and Alicia. Hi, everyone. Give me one moment here. Let me share the screen. Just want to make sure everyone can see the slides, plus the two of us. Okay. Wonderful. So welcome to our presentation about atomic hands. I am Dr. Alicia Wooten. My appearance right now, I'm wearing a blue V-neck shirt with long brown hair that's slightly curled. My identity and background is Japanese American. And the background behind me actually is a gray and white wall. And hi there, my name is Barbara, Dr. Barbara Spiker. I am wearing a dark blue shirt. I'm a Caucasian woman with red curly hair with a gray background behind me. I do want to clarify that this presentation is geared towards what it looks like behind the scenes for Atomic Hands. We will not be going into discussion about specific STEM signs today. So this is more about how we set up our organization and what that process was. And we'll talk about our future plans and what we plan to do. So we were wondering who's in the audience. We'll release some polls right now. And the first question you'll see here. The poll should pop up, as you can see that. And the question is, who are you? Do you identify as hearing, deaf, deaf-blind, latent deaf, or CODA? So go ahead and vote. We'll give you a few seconds there to answer that, and then we'll share the results. And right here, we have about 67% hearing, 31% deaf, no deaf blind, 1% latent deaf, and 1 CODA. Now we know who is here. Wonderful. Another question that we can ask, what is your level of STEM knowledge? So we'll pop that poll up here. Minimal, moderate, or extensive? Give you a few seconds to answer that, and then we'll review the results.
Okay, so it looks like about 44 people said that they had minimal, 40% were at moderate, and extensive, we have 21 people at 19%. So it looks like we have a lot of variety of different knowledge levels.
Next question. Do you like STEM? 3 options are yes, somewhat, or no.
We can go ahead with the results.
All right, 77% say yes, you love STEM. 52% say and 1 says no, they do not like STEM. Okay, perfect.
That's fine, I guess. So again, with our names and who are we, you know, what our upbringing was like, what our educational background is, we're just going to go over that briefly for all of you. So I was born and raised in San Antonio, Texas. I was mainstreamed. I was the only deaf student. So I didn't have much ASL. I grew up speaking, having to read lips near the front of the class and missing a lot and trying to rely on other students and had to learn a lot for myself. I was the only deaf person in my family. The rest of my family didn't sign. My parents would sign a little bit, minimally. So I had always called myself bilingual because I knew English and ASL. But today, ASL is my primary language. My background as far as education goes, I have my undergraduate from RIT in biomedical studies. I took some time off. I wasn't sure what to do. And then I decided that I wanted to go ahead and pursue research for my post-baccalaureate research and education program from the University of Rochester. And when I entered my PhD program at Boston University, the topic was molecular and transitional medicine. And I had a focus on pneumonia. I became an assistant professor there, at Gallaudet. So what I do every day varies. I do enjoy being outside, doing outside activities like hiking, kind of. I have a story that I can share with you all later. I like scuba diving and snorkeling. I enjoy kayaking, traveling, just anything in general that is near being near water. I also love to stay indoors. I like to do arts and crafts, things that involve working with my hands, woodworking, building a bed, dining room table. I love taking care of my plants and growing them. I also enjoy spending time with my friends.
Thank you, Alicia, for your background. Now, my background is I grew up in Rochester, New York. I do have a deaf family, deaf parents, and 2 deaf brothers. I grew up signing ASL. That is my native language. I don't speak or use English. I went to the deaf school in Rochester, K through 12. During 9th through 11th grade, I actually did do half residential school and half mainstreaming school, taking various classes that the deaf school did not offer. As you can, go back just one, there you go. In that picture there, I was an astronaut. As you can see, I'm from the USA, from the Rochester School for the Deaf, going to the moon. Educational background is similar to Alicia. I went to RIT. We were there at the same time. I got my bachelor's degree in biology. Then I went to the Northeastern University 3Cs program, and then got my MS in marine biology. Then I went back over to Oregon State University, where I got my PhD and degree of integrative biology and marine sciences. And now I am a postdoc with the University of California, Santa Barbara. It's almost exactly the same as Alicia's, as you can see, because we're friends and we do a lot of things together. I greatly enjoy being outside, hiking, backpacking, camping, things like that, scuba diving, snorkeling. I just started enjoying kayaking. That's been fun so far. I do love to travel. Alicia and I travel together quite a bit together. When I'm home, I guess video games, board games, watching Netflix. It's a nice way to disconnect from work and school. And I do like to read books. The idea of reading books happens more than actually reading the books, though.
Okay, so to back up a little bit about our stories and where the two of us met, how we became friends. So really that starts with both of us entering into RIT at the same time. We were exposed to the same group and said hi to each other, but we hadn't become friends at that point. So we had said hi, you know, but we hadn't interacted much more than that.
I'd say until, yeah, my sophomore year or so. At that time, my major was biology. And I had gotten, RIT had gotten the National Science Foundation scholarship money for deaf and hard of hearing students to do some research. So for graduate school. At that time, I was a sophomore. I considered it. I wasn't sure if sciences or that's where I wanted to go. They encouraged me to do so. So I applied and got a scholarship for that program. And I had a mentor at RIT, Dr. Hillsweed, and studied sea urchins and different animals and focused in the DNA level.
And I was waiting until, I think it was my junior year, that time when we were doing the foundational research, and I had joined another lab, and I realized that group I wasn't fitting in. And I realized that you were in the other lab with that professor. And so I decided to join into your group. And we got to know each other and then, you know, interact more. And doing our research, what happened was just one day as we were getting near the end of our senior year, we had plans to go to Europe for about 5 weeks, backpacking across Europe. But there was a problem with someone who they had to stay home to go to work, and it was just me. So I thought, you know, what am I going to do? Am I going to stay or am I going to go by myself? And I remembered in the lab meeting that Dr. Spiker Barbara might have been interested. So I asked her and she said, yeah, sure, why not? So we decided to go. And that's how we really became close friends with each other. And when we graduated senior year, we went to Europe and really just became close friends. And we were best friends after that experience. And we've traveled to a ton of different places together: Germany, Brazil, the Grenadian Islands, the Caicos Islands, Mexico, Denmark, and we'll explain that a little bit soon. Later, Belgium, Holland, the Netherlands, all over.
We have traveled a lot, means we've had a lot of time to think and discuss ideas that's led us here.
Yes, we've had a lot of deep philosophical discussions and just shared our innermost thoughts.
So that was 2007 when we got into RIT, which brings us to now. And our journey has been winding in terms of a deaf scientist. And we really struggled. We faced a lot of different adversities. There aren't a lot of deaf people within this field. I feel like hearing people aren't as integrated or aren't as familiar with access services and whatnot. So finding a quality interpreter, especially who's knowledgeable in this field, PhD level knowledgeable in this field, is very minimal. Interpreter fatigue, trying to interpret for the interpreter and figure out information. Finger spelling, incorrect translations. There was a lot of English within that ASL, which made it twice as hard for us versus our hearing peers. So we were just exhausted. We spent a lot of time venting to each other our frustrations, our experiences, feeling lonely and isolated and burnt out.
And we also recognized that we were also relying on each other too heavily. But who else were we able to rely on at that point besides each other? And so that caused a lot of wear and tear through both of us, that, you know, we realized we needed more people that we could bring into this discussion about how we felt. So really that wasn't that long ago, but 3 or 4 years ago in 2017, we partnered with a woman named Aster. From Norway. I'm sorry. We had both researched the lungs. We were both in the same type of study, and we were both deaf. And so when we found this presenter for a deaf academic conference, we shared our experience as being one of the only deaf people, one of few deaf people who were both mainstreamed, and this person was as well. We were at a DAC conference, and I asked Barbara to join me as well. And Barbara said,
yes.
Yeah. And so when we went to this presentation, they were focusing on several different STEM fields where we were learning signs at the DAC conference, and we saw the international people that were using that exchange of signs, and we started to pick that up. And through interaction and meeting with different people, we left feeling empowered. You know, wow, this is really, really amazing. There were 20 or more deaf scientists, engineers, supervisors, IT specialists, all interacting. And so that really started the spark. And at the same time, we were going to the bottom 2 pictures you can see. We had gone to visit the Atomium in Brussels, Belgium. So you can see us there. That's the sign for Atomium.
Mm-hmm. And I remember that specific moment after the DAC conference had finished. I remembered that we had gone outside. It was nighttime. We had just eaten dinner or something like that. But I felt like at that moment, we knew that experience connected us with other scientists, and we wanted to bring that back to the United States in terms of networking and accessibility and whatnot. So we just blew up from there.
Yes, for that entire week of discussion and how our ideas were, what we were envisioning and what we were hoping to see. One second, okay. So now, back in 2017, from that summer, we had been discussing, and then January of 2018, we had gone, and that's where we decided that, you know, yep, we were just going to pursue this, no more waiting around. And so we were actually on the beach, and we thought, you know, what is our name going to be? We have to network, we have to get people involved, but what are we going to name this?
Yeah, we brainstormed for a while, trying to reflect our goals, reflect us personally, reflect our community. So we had looked at other organizations, their names and ideas and signs. One that had come up was the Daily Moth, and we liked that. It was inclusive, and moth, reflecting deaf people tend to flock together towards the light. You know, in the kitchen, moths tend to be drawn to light. So it was obviously ASL within the name. So with a little abstraction. So we tried to think in terms of science. What's the foundation of life in science? And really, the atom. That is the most basic element and building block to life that we see today. So on the atom. And how can we fit the deaf community with that word? So we're thinking atomic signs. We were trying to think how to relate those to the goal of science, the vision that we have, and try to express all of that. So since the atom is the basic foundation, it's also typically something it could blow up. It's explosive, as we all know, and explosive ideas and sharing information, something like that. So we thought that vision, how can we put that into sign language? So atomic signs, we played with that. And we thought of maybe a logo design. We weren't sure, something maybe with the hands and something inside it. Eventually we had the fist and then the hand. And then we came up with the logo, as you'll see here in this video.
So that really was the first day that we had thought about creating a sign name. And Barbara and I were just playing a game that night, a science game, of course. And Barbara said, yeah, go ahead and try and sign atomic signs. And so that was me in the middle of eating and everything. So we were practicing and, we said, yes, that's right for us.
We have video documentation with that. So we were thinking vision and sign and vision sign, kind of, they all come together.
Yes. And, the visualization of science and how you can add communication and that aspect to it, we came up with the sign for atomic hands. And that's how we ended up creating our logo. We wanted something clean that was inclusive and clear, also with a little bit of deaf. It was related to deafness, but it was a more subtle nod to our deafness. So now we want to turn it back over to you a little bit. We have another poll. I'm just curious why maybe you haven't enjoyed STEM so far. So please feel free to type your responses in the chat. What's the reason why people don't typically enjoy STEM? Fear. Okay, I see one of those in the chat. Science isn't always easy to understand, or we've had boring teachers. The teachers aren't motivating us to learn. It can be complex.
Dry.
Communication barriers, it's dry. There are a lot popping up here.
It seems a common theme that we're seeing here, which we'll talk about next. So that reflects what we see in the chat, what we have on the slide here. People hate science because it's too hard. It's really hard to understand. It's boring. It's dry. Has very jargony. Has very big words. Rote memorization, possibly. We have to memorize certain things, and you may not fully understand it. Weak science communication skills. You may be able to memorize something, but you're not sure how to apply that to life, meaning that information may not stay. People who teach in the STEM field aren't able to communicate. They may not be able to deliver that information clearly where people are interested in learning. In the STEM field, there's a lot of issues and topics that talk of lack of connection between science and the real world, and then persistence and perish. A lot of people stick with this field for a short amount of time and then leave.
So everything that Barbara had just mentioned, that became part of our mission. And that was part of our goals, to have these 3 different layers. And first, what we really wanted to focus on is we wanted to encourage people to consider and get curious about STEM, to have resources in ASL and ready to provide.
Second piece was we wanted to empower the deaf community, to encourage ASL within the STEM field, playing with ASL, play with the language, be a language artist. Take the concept that you hear in science and make it 3D, or make that topic interesting and fascinating in sign language.
And our last goal, as we had mentioned before, is that we were relying on each other too heavily. And there were many deaf scientists and STEM professions within the deaf community all over the world. And so we wanted to leverage that community. I was doing research with the lungs. Maybe another deaf scientist was doing research on another organ, and that we could collaborate and interact and we could support each other.
So previously we had asked, what are the different reasons people dislike the STEM field? Now thinking, why do deaf students hate science? That's a specific and special challenge that hearing students may not have. How that information is being presented and delivered is inconsistent, and maybe information is not clear, not conceptually accurate, and often it's fingerspelled, or you invent signs on the fly. We have to figure out a specific sign for that moment, like photosynthesis, PS. In that moment, we just shorten it and we don't know what it, we just kind of skip and find the loophole to move forward without discussing the topic. As I just said, fingerspelling, inventing signs, meaning our ASL vocabulary lists and signs for this are missing. Which is not true. The ASL is young, what, about 200 years old. It's still developing, and English has been around for some time. So now it's really, I feel like, our time to make the language a little bit more robust. Any good scientist must communicate three things, I believe. Vocabulary. We should have meaningful signs. When we communicate something, we have to pick a sign carefully. Same with a person who is speaking English or communicating something. They are careful with their word choice. That's the same thing in ASL. Also, we believe that scientists communicate our work through videos. That's an effective way to do so. Having the signs ready, and that they are good quality. Meaning, instead of relying on just fingerspelling or initialized signs, we're using our language to express that STEM concept fully.
So sometimes if there's no sign there and we're trying to explain and expand upon it, the concepts are readily available without having to fingerspell sometimes.
And that's the big question. There's a lot of people asking us why we really believe in quality of the STEM signs that we choose and why that is of importance. For some time, obviously, we've fingerspelled or had initialized signs. That's what we've used. But often we aren't really looking at, in terms of the fingerspelling, you really understand the concept behind that word? Sometimes we're able to learn and use that, but later people ask, what does that mean? It really shows you fully didn't understand that concept. So with variables in math, growing up, we just signed V. We shook the letter V. And people have asked, what does V shake mean? What does variable mean? And I knew how to use it in context within a math problem, but I didn't know exactly what the concept of that word meant. And we just pick up signs. Typically, when we used to talk about filming, this is what they would use for film, because it was the squares from the film, but that would represent different numbers and how many films you had. But now we understand the concept of where that sign came from. But when we think of STEM signs, it relates to other concepts easily. In terms of energy, or heightened energy or lessened energy. If you have E on your arm, you can't really apply energy to other things other than your body. So that's where the quality of signs is really meaningful and powerful, of how we present those concepts clearly, and how we can give students a little bit of a rest and absorb the content versus working so hard to interpret what you mean.
So everything Barbara had just mentioned leads us to this idea and the belief that English and ASL are equivalent, that English does not overpower and is not better than ASL. And so, we've been ingrained to, think about English, but we are missing out on the beauty of ASL and taking advantage of that. So when we are teaching deaf students, and I'm guilty of this as well, if it's a challenging concept, so it's important to understand this isn't something that happens instantly overnight, but we have to figure out how to separate those two languages. Because we'll typically sign, explain, fingerspell, 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 and that allows English to dominate and intrude upon ASL. And so it's being oppressive and restricting the ability to succeed in ASL. Other bilingual students will typically ask if they're learning one language, for example, English, and they're going through that process. And once they're learning, maybe, for example, they have an afternoon French class, students typically have to process the languages separately. We're functioning in English at one point, and we're functioning in French in another. But with ASL, that doesn't happen because English is also sometimes intrusive in ASL. So it's processing two languages at the same time, which is very overwhelming. And so that's something that we've realized over the years. And English, we're used to using English to explain concepts, but ASL, is it better or not for more in-depth concepts? And that was the goal for Atomic Hands, was to show how we can take complex concepts and we can explain them clearly in ASL.
And sometimes ASL can be great with that, or English.
Yes, and one English paragraph could be one short sentence in sign language. So just to go over again, when we had asked deaf students to fingerspell and then to abbreviate signs, our sign progression typically happened in English word order. So that was really in conflict with the ability to learn. So it seems like we're trying to purify ASL, but at the same time, we're not trying to remove fingerspelling or abbreviations or acronyms. We're just trying to make sure that the concept that's being conveyed, how do we represent that in the native language appropriately? And so, for example, if we have deaf people that are, in the woods, we stick deaf people in the woods, are they going to use English, or would they end up creating signs and being able to communicate with each other, figuring out how to visually communicate?
And that's with no contact with hearing people. If we were to, did they naturally invent fingerspelling? That'd be something, it'd be fun to see.
Yes, and in the bilingual world, it's important to recognize both languages independently, but really we want to encourage people to start the analysis of themselves and think of, what would be the right sign? What would be the right approach to this? Are we fingerspelling? Are we making acronyms and abbreviations? Are we replacing it with something better? Could we replace it with something better that would help students to comprehend this concept better? So for example, the word photosynthesis, the process a plant uses to grow. But if we abbreviate it to PS, why aren't we using a sign that incorporates the sun changing a plant and helping it grow? So that concept is portrayed rather than the abbreviation of PS fingerspelled. So it's taking ownership of our own language.
Yeah, as Alicia mentioned, it's common in the STEM field. Typically, English is important. The words you use are important, and ASL will learn that later, but you need to learn the English. Um, but that perspective starts from youth all the way through school. We internalize that idea, and so we want to think about that a little bit. School aside, but if you're at home and you're talking with other members in your family, are you talking about STEM? Are you talking with friends and family and children about these concepts? And how do you, using your primary access of language, which would be ASL for some people, using ASL, having that conversation, and the goal would be to deliver a message back and forth and understand each other. Obviously, we're not trying to say, make sure you understand this word, fingerspell this word, but really, do you understand what I'm saying within conversation? We want to parallel that within the academic environment. Because often we think English is important and we try to cram English and ASL and it can get muddled together. It's more like we're trying to assimilate with hearing people. And that just makes it harder for deaf students to learn and understand STEM concepts. So assimilating our identity, our intuition is a little bit stymied. So that aside, trying to think about talking with friends or family in everyday life, the way we use our signs and the way we use our concepts, using that within the educational setting. English is important, absolutely. ASL is important. Trying to honor both of those languages and thinking how to integrate them together might make it easier for students to learn.
So words in English and words in ASL, they might end up changing, but one second, but the concept remains the same. I got a little bit confused with my slides. So the concept doesn't stay related only to the English language. English is not the owner of scientific concepts. Those can be made clear through ASL.
So we see the different points here. There may be new signs that you haven't seen before, and people wonder where these signs come from. Are they just made up? But we actually are taking them from various places. There's 5 points here. The first one being ASL STEM dictionaries. There are some out there available at this point, and they do have some signs, and we incorporate them into our videos. Those STEM dictionaries behind them, those people who develop those are from deaf experts, people who brainstorm, and our current signers, they may not be in the field, they may not be incorporated with all of this, but they are, this isn't something that just happens overnight. This information takes years, months, days just to try to figure out the appropriate sign and concept to reflect that concept within a sign. Another one is a big part is the ASL test translations, where we have to translate tests into ASL. That really challenges people's thinking and how to interpret this information equitably for students with questions and answers and choices. I can't just sign and then fingerspell the words. That's typically, that would be just like them reading, and that's not equitable. So deaf people have to think of how to express this information and this concept into ASL. So that has come up.
And we've also pulled signs from other deaf STEMists. We've done the research ourselves. We've dove into it and looked at PhD programs we've experienced where fingerspelling, we had to develop signs to make it more efficient, and understand that it wasn't Barbara and I, it wasn't our decision alone to decide what was the correct sign. We were trying to think of signs. We would video ourselves and pick what we felt right for us. But that doesn't mean that it's right for everyone. That doesn't mean that it's right for you. No, sometimes we like to test different things do a new sign and try to see, you know, how the community responds to that. We were doing this with a goal of hopefully sparking a discussion and, you know, leading to thinking about, you know, whether or not this sign really fits or what we have been doing really fits. And it allows us to initiate that feedback to see, you know, what we use in our everyday lives. Maybe we can pull from that to make adjustments and then share that with all of you. So we just wanted to emphasize that the signs that you see, we don't always create it from scratch. We are pulling from things that people use. If there's a typed transcript and we don't know what this word would be in sign, we would look at international dictionaries, or we would video chat with different individuals, and then maybe people don't know about it yet. So this is an opportunity for discussion. We're not here to establish this is going to be the sign for this concept. We are just putting it out there to see what you all think, if you agree or disagree with what we've come up with. So one great quote from one dictionary in the community, ASL STEM Forum, says, language use and evolution cannot be dictated by the few, no matter their expertise. Instead, languages change because their users choose to change them. So this is not just the two of us. This involves all of you as well.
Right. And through that journey, Alicia and I have had similar experiences growing up with our signs, and someone tells us a new sign and we think, no, I like mine better. I like to spell, or my specific sign I use, this is just clearer. But over time, we have watched various different movies or whatnot. But finger spelling is important, yes, but it might be for a different time. We're open for discussion, and we're just encouraging that people use ASL in these settings. So with that, good scientists, communication, one is vocabulary, two would be discourse, how we deliver the message, how we entice people, engage people to be interested and care about the information we're sharing or want to learn more, and how do we get people to think critically about our posts, about what we post and what we talk about, engaging in comments. That would be number two. And number three, knowledge, understanding the topic. STEM have specific nuances and differences and information and accuracy. We want to explain things correctly and use correct signs. And you can't do all of that without knowledge. So those are the three things. Meaning, discourse, and knowledge is good science communication, allowing people to receive that information and connect it to their world and what goes on around us. So I'm going to talk a little bit about this here. I'm sure some of you have seen our Atomic Hands videos before, and we were not born and ready with all this information in our brain. So I'll show you how our signs have evolved throughout the years. A lot of years of practice, a lot of blood, sweat, and tears and heartbreak over these. This has been quite a journey. So I'll show you our transformation. The first sign and first presentation as a duo, we were looking at sea urchins and brittle stars. The next video I'll show you is, it might be a little bit blurry. It's not very clear, but I'll give a context of what you're going to be looking at so you can see here. So this presentation, we have talked about sea urchins and brittle stars, their development from baby to adult, basically at the DNA level. We did a quick summary of the video, and I'll explain what signs we were using. But the point of me showing this video is see how much I finger spell and how many initialized signs I have and signs that I used in incorrect context. And that information may not be interesting. It might not be engaging. and this is just 4 short little clips. The first clip I'll show you, Alicia introduced the presentation, and she'll start by saying, endometrium. She's talking about specific patterns and where they, specific areas and evolution of these animals' lives. And when she signs specific, the word specific, it's not the right sign actually in that context, because sea urchins, when they're within this phases, and then it goes over to me and I start talking about different animals. I'm finger spelling different areas of their body. I'm talking about their skin. I'm talking about the legs of the brittle star. They go through different areas of how they feed and how they move through the ocean and as an adult. So I go through different phases of when they were small to much bigger. But I'm not very animated. You can see that I'm quite flat-faced. And third, Alicia is talking about SU and having 2 groups. And we have primitive and derivative. And those concepts mean which their ancestors, they didn't get those traits from. And then the fourth one, I talking about notch, the signal for notch, which goes into cell nucleus, which I initialize. So you'll see here. So you can see here, the point wasn't for full comprehension, but basically for you to just see this is dry.
And so that time I'd only been signing for 4 years. So you could tell that that was my first big presentation in front of a large audience and that I was nervous. So my mind was just set on English word order, finger spelling.
And like she had said, I'm set on English word order, and I want the interpreter to follow the script and say the words and exactly what we have practiced. But I wasn't able to be myself.
So now fast tracking to 2018. So that was, several years later. We were doing atomic hands. We had set it up about a year prior. So now we were discussing mosquito bites and explaining that when a mosquito bites into skin, how and what was happening below the skin surface. So if you watch this video again, you'll come to the realization that, we're doing a lot of things differently. And you'll notice that we are very stiff in our signing. We're focusing on what the message is, but we're not sharing the whole story. And you can see that our ASL is a little bit choppy and staccatic. And you can tell that my mind is not completely linked in and fluid with the process. So now watching that now and looking back, I can think of all the different sign choices I could have used. And, you know, what I did wasn't clear, where the bite swells up and becomes itchy. So from 2011, 2018, we've still been evolving and making adjustments to these sign choices.
Right. And that evolution had us thinking how we express, how we use space temporally. And so we've expanded on different topics that we have used and used in videos. We focus more on showing signs, on how to use things within the correct context, STEM V, STEM and ASL, just fun facts about STEM topics. Spotlighting different STEM scientists. And last one focused more on user-friendly, trying to get people engaged on different topics.
So you can see that we have a variety of different videos for different backgrounds of what things would look like. So this is in an office in Gallaudet where I'm discussing different signs for viruses. And the next one is during our travels. We were in Oregon and I was helping Barbara with her PhD research work on beachfronts and oceans. So we were looking up and down the Oregon coast and we had found something. We had found plastic from the beach and that people had taken and become art and had used it to become art. And so that's what we are signing about in that. And then there's a formal video where I have posted the different squares and you'll see a lot of information. So we have a variety of topics for different types of scientific communication. And, you know, how we made all of this, that's what we're going to show you.
So this shows our workflow from A to Z in final product behind the scenes. We'll share that with you now. We start with identifying a topic. Alicia can go to the next slide here. We'll show you. So we identify a topic. That's our first step. We pick the topic. Typically, people send in requests or give us ideas, or we notice that a lot of people have asked about this certain topic. So we'll make, whether it's today related with climate change or black hole, or what other ideas have come up for us. Anything about space. So we think of a topic, we research and whatnot. We try to make sure we have all the areas in it: science, tech, math, and whatnot. Technology is a little bit weak. We need to get a little stronger on incorporating that in our videos.
And then once we've identified a topic, then we move on to the research phase, where we look online, we look at different scientific articles and also popular scientific magazines and journals. We check to see if there's already been a YouTube or social media video. Sometimes books also will have cool facts or images that we can also pull and use from. We also make sure to fact check, because if we find something, we want to go ahead and confirm it to make sure that our information is accurate.
So after we've researched the information, the next is to write a script, an English script. And we'll break down and follow a good storyline. We have a hook that keeps people interested and engaged, related to people's everyday life so they can connect with the concept. A lot of metaphors and parallels for people to understand. So we start with an English script, and you may wonder why an English script first versus ASL. An ASL script can be gloss, which will take that English script and then make it into an ASL gloss. We have limited time as we have lives and jobs and whatnot. So we're trying to think of the most or the least time consuming, and getting an English script out first is ideal. We'll take that and then translate that into ASL. And then the English script can become captions. And if people want to write a script for us or send us a script, we'll be able to do something like that as well.
And again, is this exactly what we do? No, sometimes we make adjustments. We'll have a script, but signing it, maybe we'll decide to change it a little bit. But also we have to practice. We can't be awkward or, not smooth when we're trying to do this quote unquote new ASL. I grew up orally, so I was speaking. So this was also an adjustment for me as well. It's really important to practice ahead of time before we record the videos. So we had to figure out how we wanted to portray the story and express it. So sometimes we had to research, choose the appropriate stem sign and play with the ASL. And sometimes it will become frustrating because in your mind, it's hard to get that out onto the hands.
Because like art, we all have our own different way of expressing. It's kind of like an art.
And it's really important. Barbara and I have very different styles. So to note that sometimes it's hard as a language 2 user of ASL to put it out there equivalently, but we all have our own styles. So we have to learn whether something's new or you're just learning something later in life. Anyone can do this type of signing for scientific communication, absolutely anyone. So anyone that might be hesitant, just try. You have to practice at it because 2 years of having atomic hands out, we've still been making these adjustments, and it's a work in progress every single day.
The next step, after we've rehearsed and got the script down, we film and deliver this in ASL. We don't do it all in one shot. We've tried. We realize there's a lot of mistakes and we have to restart. As you can see here, has a lot of different films. That's all mistakes, one after another. But we'll do section by section now and edit that together. That's a little bit easier for us. So we've tried a lot of different strategies of what works best. Typically, we'll read the section and then sign it from memory. Sometimes we'll have a teleprompter. Alicia, explain your part, I guess.
Yes, and I'm also just absolutely terrible with memorization. And science is heavily relied upon memorizing information, but I'm just not good at it. So that's where I struggled a little bit, and I'd have to, repeat stuff and practice time and time again. So I needed to figure out for myself how I was going to arrange it so that I could follow an English script, but sign an ASL, and I kept messing up. So the approach that works for me is to read the script until I understood it completely and then portray it and express it in the way that I wanted to tell the story. So that could be completely different between how Barbara does it and how I do it.
Right. We have to remind ourselves that it's easy to get sucked over to the English side. We need to remember, let go of the English, envision what the concept is, and then express it in an artistic way, as I said. So next slide here. Oh, yeah.
Yeah, so once I've completed the signing portion, we will review it. I'm going to watch through and think, maybe the space wasn't used appropriately, or one of my non-manual signals was off. Maybe I fingerspelled unclearly, and so we'll go back and redo it.
Once the film is edited and correct and ready to go, we'll use it in an editing program together. And we are no film buffs, so we had to learn on our own via YouTube, asking others how to do this. And it was definitely a learning curve for us. We edit the video with the logo or picture behind us or special effects. We add captions to the video or a specific file to it. An SRT caption file.
And at the end, when we have our videos ready, we'll upload them with a blurb and also with an ID below. So we'll have individual we will individually upload them to different social medias.
So another poll for you all. When you're thinking about a 3 to 4 minute video, how long do you think it takes for us to do this from start to finish? 30 minutes, an hour, 2 hours, 4 hours, 8 hours, 10 hours, 15 hours, or 20 hours?
We'll give people maybe 20 seconds to answer. Okay, so now that we've seen the poll, I'll tell you what the actual answers are. So we have a different breakdown. And so altogether, the total hours will vary between 8 to 13 hours, depending on what the topic is. If it's something that we're already familiar with, it might be a little bit quicker of a process. But if it's a new topic or harder to research, it might take longer. 15 minutes to think about a topic, and 1 to 3 hours for research, 1 to 2 hours writing a script. We have to translate it from English to ASL, which takes an hour. The film and delivering it in ASL takes 2 hours. We have to set up the camera and do several takes. We review and revise, which takes about an hour. And then the editing and captioning of the videos is about 1 to 3 hours. So if a program freezes, if a program dies, if we have to restart it, so that can take up to 8 to 13 hours. And the release of the video also takes an hour.
So we've talked about what we've done for Atomic Hands videos. One example we had done before was the National STEM Day. We used that to talk to the community more about the STEM field and make a STEM video related with your work or really any topic with the hand shapes 1 through 5. As you know, people do in the deaf community. So we had a lot of video submissions. It was really cool. We want to show you a few of those.
Yeah, so we had different, Facebook, there was a video of a woman working in a lab and what that looked like. And she was working with different samples, different sample tubes, and adding chemicals to those. So once it would close, we wanted to have all of the liquids to shake them to the bottom in something that is called a centrifuge, and that would spin to separate the liquids to the bottom.
And that shows the 1 through 5. And the next video is showing some math, showing a teacher engaging with a student on how to use a graph using 1 through 5 and then going back at 1 through 5, then 5 through 1.
This third video, we're discussing the growth of crops. And we noticed, noticing that one doesn't grow well. So in the lab, we can make genetically modified organisms. And so we show the gene sequence and how that's edited to create a GMO crop. Go ahead. Oh, you noticed that those 3 videos beautifully show scientific concepts using the 1 through 5 or 5 through 1 hand shapes. So people that say, this has to depend on English, we have proof to show the contrary.
It was a fun activity. I hope we can do more of those in the future. So we had that video, and then we also are hosting workshops. We just briefly touched on the 3 important areas for communicating science, but we are showing different activities, different samples, different signs in STEM for this workshop. We hope to have different topics for workshops, and we will be in touch soon with those.
We also have different K through 12 programs where we provide hands-on activities to the kids where they can play and build something and then test their creativity in what they built. So this was at the Florida School for the Deaf and Blind. This is where they were building plankton, a great plankton race. That was what the activity was, to see, how they could build that model. And it was a hands-on activity for the students to play around with and really utilize their creativity.
So we've touched on what we have on our website. There's a lot of information there if you want to check that out. If you open the homepage, that's what that looks like there.
And so uploaded there, you can read and you can see all of our different things that we have available.
We have different STEM news, different people who we're recognizing and spotlighting and different information. So you'll see articles there.
Also, if there is a camp, there's an event or a webinar, we also post that to share with everyone.
The website has different deaf resources. Could be health related, could be archaeological, different fields.
We also have dictionaries.
And one of our biggest goals is to encourage more deaf people to be involved with the STEM field and discuss the STEM field. So you can look here for a different STEMist network.
And if deaf STEMists sign up, we have a network right there for you to do so.
We're almost going to close, but we'll summarize a few points here for you. The reason we're doing this, we really want to encourage ASL to be involved in the STEM field and let go of the colonization of hearing and English. And empowering the deaf community to take a look at themselves and ASL and STEM and what these concepts mean and bring it to the community.
Future plans. So really, it's not just about the 2 of us. We're looking to expand. If you have an interest in making videos as well, please contact us. We need more people involved. And we want to spotlight you as well. We hope to host more K through 12 activities, more conferences, and just collaborating and networking with as many groups as possible.
So lastly, you think, what can you do to stay engaged? There's a lot of things actually. Start the conversation with others about STEM. We need you to create STEM videos and encourage others to do so. Critically and constantly empower the deaf community to take ownership of the signs and the concepts themselves. Could encourage other deaf people to sign up to network with this field.
And also our website, if you want to see everything again, that's where all of the information is. And that's where we're gonna, cut it.
I'll stop sharing here. Wonderful, wonderful presentation. Thank you so much. Before the audience leaves, we want to leave it open a little time for Q&A, so do stay. The next month's series we'll share that information as well, so stay for that information.
So there is a list, so I'm just gonna try and go through the Q&A. Noe, are you ready?
Yes. So next month we have Justin Perez with our ASL Connect lecture series, and he'll be talking about visual vernacular, about signing stories and whatnot. So sign up and save the date for next month's lecture. So we'll get to the Q&A for Atomic Hands now. The first question, yes. Is there an entity that officiates signs and similars to Webster adding to the dictionary? This is Barbara. I can't really answer that from my limited knowledge. I would say both. I guess ASL is more spatial in processing, same with any other language, I'd say. But that's the limitation of my answer.
Yes, I think the diversity is important. So we value different perspectives of deaf, hard of hearing, people with other disabilities. It's not just one standard perspective.
Next question. What's your experience in terms of navigating school, in terms of interpreters and whatnot? The quality of the delivery of the information.
So I think our experiences were both good and bad. I've had some really great interpreters, especially at RIT, and I love them for it. But again, the vocabulary itself was lacking. So it was relied heavily on English and finger spelling and abbreviations. So that becomes a huge challenge for us to have to watch all day, day in and day out, and to be able to retain information and understand it that way.
And this isn't a blame on the interpreters. The interpreter hears the information and then interprets it. And that processing is obviously a highly demanding and exhausting job. But it will be lovely to get that information directly. It's just easier. It's always easier to get that language directly in ASL. Even some through the best or worst experiences I have, it's just a journey you have with learning.
Right. So, back to what we had said, vocabulary, knowledge. The interpreters have the knowledge. If they have it and they're able to explain it, then it's conveyed a lot more clearly.
That's a good tip for the interpreters. The next question. So adding words to the dictionary, what about signs? Are we able to do that? There's really no place to document that, or like we don't have a Webster's, we don't have an actual physical thing like that, but we have different sources and resources out there. There's nothing centralized at this point, but we're thinking of, I guess, word of mouth. It's just basically shared, and that's how language evolves. Alicia?
Yep, I think she said everything perfectly.
So just to challenge you two, the concept of science without any English being involved, no mouthing of words or spelling or anything like that. Describing something purely in ASL, do you do that? Is that possible? Yeah.
Yeah. If it's something, on the spot, is it going to be perfect? If it's spontaneously done off the cuff? No. But with practice, yes, you can do that with anything. Like those stories that were beautiful, 1 to 5, 5 to 1 hand-shaped stories. It is very possible. But doing something, spur of the moment is not going to be perfect.
Yeah, we're trying that and we've done that. And it's just proof to us that ASL is equivalent or above English in that 100% you can do it in ASL. Agreed. It is equivalent. Next question. So growing up mainstream and learning math, watching the interpreter, watching the teacher write on the board is tough. And I barely passed math. I wish the teacher or interpreter could have done better. Any advice with that? I don't really have a direct answer for something like that, but right, while learning through an interpreter and then looking at the teacher and still trying to learn the information is definitely a challenge. There's no right way. I guess it's constantly moving and shaping for each situation. And often, typically, when the teacher writes on the board, they pause, let the interpreter see the information, interpret the information, and then teach. Giving that material or information ahead of time is possibly an advantage. So someone is prepared and can connect to that information in the moment. More hands-on activities to retain that information versus just oral lecture.
Yeah, so looking back to my mainstream experience, so I was taking calculus and I think I might have failed or I was close to passing or close to failing, but without interpreters, just having the information projected, it would very quickly go over my head. And I didn't know how I was supposed to be successful in that situation, but there is no easy answer. It depends on how you learn math and how you process. If you need maybe a teacher to sit with you step by step, then ask for it. You know, for me, I needed that one-on-one. I needed the teacher to show me step by step sitting next to me and then teach me step by step. And once I had comprehended the first step to move on, the problem is relaying that information through an interpreter or just teaching the class as a whole. There were gaps. So you need to combine those work together.
We often put the burden on the student of what can we change? How can the student change? But really it's how can the teachers, how can the system change instead of putting that onus on the student themselves?
Oh yeah, everyone can learn, you know, how they're learning math like this.
Thank you for sharing your experience. Yeah. Putting the onus in the view on the teachers or the system. Mm-hmm. So in terms of teaching my students science, the state tests are printed in English and the students have to take that state test and they often fail. So we're kind of stuck with standardized testing being in English. Alicia? No? Okay. Again, I'm not in academia field or I'm not in the educational field as an instructor or anything like that. It's always a challenge for English as a second language for students to make that jump. I feel like I'm really not the right person to answer that question. So I don't know if Alicia, if you have anything to add to that.
So my experience has all been with higher education, you know, speaking from a college level. I've recognized that with my students, if there's an English quiz, they will contact me and say, do you mind doing this in ASL? And as soon as I do, they're able to answer the question and oftentimes are getting it correctly. So obviously something is missing with that parallel of English to ASL learning. And so now doing them overlapped at the same time, they can't figure out how to learn, you know, with a strong foundation in English. They go back to the system that they're used to. So how do we change that system in the K through 12 setting will of course be difficult. You know, that's the $1 million question, definitely.
I also want to add that students learning ASL and taking an English test and failing, again, I don't know, it could depend on the situation and that person specifically, but we could request that person have that exam signed in ASL to answer, to give an equivalent, same like a driver's license exam or something like that. If someone would move from a foreign country, they may have that translated into their language. Why not have the same opportunity within K-12? True. Next question. So I'm a civil engineer who's learning ASL. How can I get involved in encouraging deaf students to pursue STEM career fields?
Do you want to go ahead?
First, our website would be a great place to start. There's a lot of different events, webinars, camps, different STEM information. You can Skype a scientist and you can talk with someone. There's a lot of different folks you could be in touch with. We have a list there, and ask questions. Or for us, we'd say STEM is hard. People think it's hard. And we're trying to think how we can be a little bit more hands-on with this material. My graduate degree, most of my learning experience is because I traveled and I did things and I did research, field research. I wasn't sitting in class and learning. So it made me like and enjoy science even more and retain the information a little bit more clearly. So any age, any background, any language, hands-on always helps.
And also deaf children, they need deaf role models who are also civil engineers. So maybe I suggest trying to find another deaf person who is an engineer that you can, partner with and work with so that people can see, what you can do with a civil engineer or what you can do with any other career path, but just to get people interested and intrigued on that career path.
Good advice for that civil engineer, having someone with them. Yeah. Next question. I'm not sure how to ask this. I realize there are several websites that focus on ASL STEM vocabulary words. Do you have any suggestions to manage this information overload?
There is a lot of information out there, but the best advice is to always go with the deaf people. If there's hearing people making an ASL video, maybe not. But if there is a deaf expert, there is a deaf interpreter, there's a deaf person sharing that information, that will help limit what pool that you can find is credible.
Yeah, there's a lot of ASL dictionaries, and it's hard to know what's absolutely correct. But we're going through the growing pains right now. The signs are being developed for the STEM field. So there's a lot of people going into the STEM field more now. So those barriers are being broken down. So we're kind of toughing it out together at this moment, but I feel like several years from now, we'll have possibly a centralized dictionary or a website or something that's much easier for us all to access. But yeah, right now we're kind of toughing it out through the hard part together. Thank you. Last question. So there's a lot of interpreters. How do we advocate for STEM ASL dictionaries? Directories that we mentioned in this presentation are part of aspiring interpreter curriculums. I see many interpreters come out completely clueless on what they should be armed with these resources.
That is a great question. And I'm always a strong advocate that whoever is training interpreters needs to specialize in that. So you need to know, what you want to specialize in. Are you going to interpret in higher education, scientific interpreting, medical interpreting? Then you need to take classes about that specific topic, not just necessarily saying in ASL, but you need to go learn about that topic field that you're going to be working in. So if you are in that field of studies class plus ASL classes, then you're able to think about it and analyze concepts and how they would work in ASL. So right now there's a lot of, your job, your responsibilities. You want to become a great interpreter for the deaf community. You need to do the prep work. Unfortunately, it is a lot of work, but at the end of the day, it's so worth it if you have a deaf person that you can provide equal access to.
And I did notice that. I mentioned this before. In the sciences or any other things like that, whether it be your first, second, or third language, but interpreter curriculum or specific workshops where we talk about ASL in the sciences, what that looks like, practice. There really aren't many options like that. So we're trying to be a little bit more creative with that and develop workshops for interpreters. New interpreters can ask what can they do to be involved in the STEM field and how to get a little bit more proficient and a little more proactive in asking and realizing what the demands are for this field. All right. Thank you so much for answering the questions. Some in the audience asked a few more questions. Don't worry. You can go ahead and get a hold of Alicia and Barbara directly after this. I encourage you to visit their website, look at their workshops, and reach out to them if needed, and they'll be happy to help you. But again, thank you so much. We'll show you the next ASL Connect lecture series here, you'll see, but thank you to Barbara and Alicia.
Thanks, everyone.